Information integration is the idea, and many of you, any of you who have been out in industry have probably already experienced this firsthand. But for those of you who have not, or have not, are in the honest minority of those who may have been in industry but not been affected by this, this is the idea that enterprises have data sources in many, many different disparate locations. So you might have your main database, you might have ancillary systems that have their own database. Maybe some of them feed from your main database, maybe some don't. You might have separate systems based on purpose or business function, like HR and finance and operations. You might have different ones based upon, mergers and acquisitions. Maybe you started your company and your company grew, and eventually you absorbed another company. That company you absorbed is going to have its own database systems, and you need a way to talk across these things, right? So we talked a lot about SQL being an abstraction that we can use to have developers access our data in a uniform way. But as we discussed, SQL isn't, it's a huge step forward, but it doesn't solve all of our problems, because a couple of things. One is there are differences in SQL, as we briefly talked about, and we'll explore more as we go through the semester, based upon which database software you're using, but that's not insurmountable. But what is very different is the data schemas themselves. So, imagine that you have two different companies and they've merged, right? And they both have user data, from one from company A and the other from company B. Now, when they both merge to become, joint company A, you want to take the user data in company B and move it into company A, or you have to be able to use your applications to connect to both of these places, or you need some other solution like a data warehouse or something that combines the information into a separate data store through some kind of feed mechanism, and then have your applications feed off that. But you run into this situation very quickly in any enterprise where data sources grow in number and they grow in shape and size, and your needs to talk to outside data vendors increases, and you quickly run into this situation where this becomes the one big central kind of difficulty in your business that you're always working around. Your data is probably your most important asset. That is almost a given. And it also is the thing that is at the core of how your applications work and how they need to function. So in order to, say, move applications forward or any of that, you need to know where are they connecting to their data, how are they getting it, if you change your database, how many applications are going to be affected, things like that. So it's a very, very tough problem. Let's take a university as an example, because it's one that we can all relate to, right? So a university or college will commonly have many different software solutions to manage different things. So I mentioned an ERP in a past video. So enterprise resource planning is ERP, and in many industries that is a central data store that has your most prized valuable data. So in education, that would be your student data, their enrollments, their transcripts, their grades, the faculty, what courses they teach, the financial information, things like that. Now, HR is a great example because some universities and colleges have HR information that's integrated into their standard ERP. Others don't. There's a separate HR application, right? So let's go down that road for a moment. So now you have a separate application with its own database. You need to have a authoritative source of user information, because I can't be registered in the ERP as Brian Gormanley and then have my address change and then have the HR system not know about that, because then when they go to issue my paycheck, if I'm not direct deposit or something, it's going to go to my old address, right? So you have to have a way to synchronize this information between these two separate databases, and that's difficult, right? Now, imagine, and this is very common, imagine you want to implement a electronic swipe access, right? So you've probably seen around campus or in other businesses, there are, electronic ways of accessing rooms now. So I take out my student ID card or my faculty ID card and I swipe it, and there's a little thing there by the door and it chirps and the door opens. Great, open the lock. Well, how does that work? So the vendor of that company actually gets a feed from your data stores, including all of your students and employees' names and their CWID numbers and what badge number they have or whatnot, and what doors they need access to. So you have to have some way of keeping track of what doors on campus are set for this. And you send that to them, and then their software takes over because it's probably cloud-based. And when the person swipes, the card reader sends the information to their cloud, and their cloud checks against the feed that you sent. And if the person's registered for that door, it sends a signal back to the door to open the door, right? So this is not just one thing for electronic swipe access. There's auditing and all kinds of vendors, and then even systems inside of the university. So look at both like MyMarist and iLearn, right? Both of those things have their own databases because they are their own standalone softwares. They have to have a way to integrate user information. They have to have a way to integrate with single sign-on. They have to have a way to integrate sometimes with the ERP system. MyMarist in particular, right? It can show you your grades and what courses you're in and all that good stuff. In fact, MyMarist can integrate with that, and it integrates with iLearn, because it can actually find out which courses you're in, look to iLearn, see if there's an actual course shell, and if there is, it will enable a link that can send you into there, right? So there's all kinds of ways that we build this whole hierarchy of massive amounts of software on top of our data sources, right? And what happens is it makes it very hard to change or sunset these data sources. There's so much dependency depending on them being holistic and clean and working the way that we imagine, right? So these integrations that we've built to create the feeds for every system to be up to date and to work correctly and send the feeds to the right place and provide the information to the auditors, all of that was extremely time consuming to build. And any changes to it are detrimental because it takes a long time. So how do we manage this? Like what solutions are out there? I mean, unless you're a brand new company and you only have one database and you can try to keep it that way for as long as possible, but I guarantee it's not going to be the case for long. How do we manage this? So there's two main solutions that I want to talk about. One is a data warehouse and the other is middleware. They both work off this same concept that we're going to build another layer of abstraction on top of our data sources. So you have all your databases down at the lower level of abstraction, and now we're going to have another layer of abstraction on top of them. Whether that layer of abstraction is database centric or application centric is the difference between a data warehouse and middleware. So let's start with the data warehouse. So a data warehouse is basically that we're going to have that second layer, the higher level layer, be another data store on top of the lower level data stores, all of the individual databases. And what we're going to do is we're going to build basically, usually it's feeds that these things periodically get sent to the central higher level database, but we're going to make connections between it and all the lower level databases so that they can feed in data. And there's going to be all kinds of business rules around these feeds. So say, let's go back to our example before with the merger. We had company A and company B and their two user databases. So you can imagine that at the lower level, there's those two original databases down below, and they both have user tables, user relations. And we're going to now create a feed to the data warehouse that maps a single table in the data warehouse for a user that we now have queries that pull in user information from database A, because the schema is going to be slightly different, right? Let's say database A has first name, last name, middle name, and age, and email or something. But database B has first name, but it's just FN, and last name, and it's just LN or something. They have age, but they did it with a slightly different data type. They did it with a long instead of an int, and they don't have email. Email maybe is in another table. Maybe they had an email table. Kind of smart, right? But let's just pretend that's a difference. That's a very common kind of thing, right? Even if it's not the email address, the idea still carries through. So what you're going to do now is in this data warehouse, to populate that user table, you're going to decide if you want the email there or not, right? You're going to have this kind of, all right, now we got a second chance to re-schema everything the way we want it. So let's say we put the email in a separate table there as well, because I kind of like that idea. So we now have a user table, which is going to have first name, last name, middle name, and we're going to have an email and age, and then we have an email table that has all the email addresses with a foreign key attaching back to the user. When we do the query to database B, let's start there. That one's pretty straightforward. All we're going to do is change the mappings between the first name spelled out and the FN, and the last name spelled out and the LN. The email is going to map directly from the email to the email, right? But then on database A, we don't have to map the names differently, but we have to then take the email and put it into that separate table, right? So you build these feeds to kind of have a coming together of these pieces. And now you have this one unified top level database that provides everything. So the second option is middleware. Now, middleware is basically a software level abstraction above these databases. So we're going to have some application running that probably supports APIs. So in this scenario, I would say I want that get to that user information, right? Same scenario. We got both databases below it, company A, company B, the original two. Same table layout that we just talked about. But this time, the middleware might provide a API level abstraction, right? So you have an API that you hit to get users, right? So you hit this API. The API then calls down to those two databases to get the users from both. Or maybe there's a data store in the middleware layer too. Like you can actually combine these two things a little bit where it's a little bit of both. And it provides that information back now through an API. But the core central difference here is that the abstracted layer is now software driven instead of just being another database driven application. And these are the two central options that people use for this. Again, there's many kinds of solutions, but it allows you now, as things change and you add new databases and take databases away, you can manage that chaos a little bit better by changing everything at the middleware layer. It gives you a central place to manage that abstraction to your data. So now that all the applications that sit on top don't have to directly talk to the different databases and make those adjustments themselves. You have one place in which you do it. So if I had, say, my ERP, and let's use that feed we talked about earlier, from the swipe card access. So both of those things needed to get user information, right? And let's use iLearn too. So now we got three. So those three things now don't have to manage database A and database B themselves. They can either just talk to the data warehouse directly as a database connection, or they can talk to a middleware layer through APIs and get the information that way. Now, the thing to keep in mind here, especially with data warehouse, things tend to be feed driven. So there may be a certain amount of time in which data is not up to date. So like if somebody changes a user information in database A and the data warehouse only pulls in the information every night, then there's going to be a little bit of lag there, things like that. So just something to keep in mind. There's no perfect solution here, but adding this layer in between all of these applications and all of these databases is a really advantageous thing to do. And that is the idea behind information integration.